Welcome to our Duralast Wheel Hub instructional video. My name is James Cox from the Duralast Technical Center. Today we'll be discussing several aspects of our wheel hub assemblies such as design, manufacturing improvements, installation procedures, diagnosis, as well as common product issues and warranty trends. Now we will discuss the different types of bearing designs. The early automotive wheel bearings were the conical design type. These bearings were normally installed on the spindle assembly. On some models, they could also be found on the brake rotors. The main disadvantage of this design was the need for regular maintenance. This design also required a precise adjustment procedure, which made it very susceptible to premature failure. Wheel hub assemblies became popular during the early 80s with the introduction of front-wheel drive vehicles. One of the advantages of using wheel hub assemblies is that they do not require regular maintenance, which included cleaning, greasing, and periodic adjustments, etc. Another benefit is that they are compact and lightweight, while offering the strength and performance necessary for passenger, light, and medium-duty applications. Wheel hub assemblies also offer a platform for mounting the ABS sensor and tone ring. This design offers lower rolling resistance, which reduces friction losses and thus increasing fuel economy. Depending on the wheel hub design, the ABS sensor can be found internally, externally, or remotely mounted. This is an example of a rear wheel hub assembly with an externally mounted tone ring. This unit has the tone ring as well as the ABS sensor internally integrated. Since the introduction of wheel hub assemblies in the early 80s, there have been several design evolutions, commonly referred to as Generation 1, 2, and 3. The latest version is the Generation 3, which is currently used in most passenger and light-duty applications. This is an example of a Generation 1 wheel hub assembly. Notice that this wheel hub assembly uses conical bearings. This unit is a Generation 3. Notice the double row radial ball bearing design incorporated into this unit. As mentioned before, this reduces rolling resistance, offers increased service life and performance while reducing noise, and improves fuel efficiency. Our latest offering is the heavy-duty line of wheel hub assemblies. These units incorporate a state-of-the-art roll forming technology which greatly reduces warranty returns due to excessive torquing. This is accomplished by the torque limiting characteristics which is offered in this design. Here's an example of a wheel hub assembly incorporating roll forming. We are the leaders in vehicle coverage and availability. Our wheel hubs are 100% factory tested and manufactured for ABS operation and signal compliance using state-of-the-art equipment according to ISO TS 16949 standards. Raceways are induction hardened for increased durability and vibration-free operation. Multi-lip seals offer superior moisture and contamination protection.
Whenever you're attempting to perform mechanical repairs, make sure to follow safe working practices, especially eye and hand protection. When you're ready to lift the vehicle, if you're using a floor jack, make sure to position it on the recommended jacking points, which are outlined in the vehicle's owner's manual. Once a vehicle is at a comfortable working height, make sure to support it properly using safety stands. With the tire off, we now have access to the components that need to be removed. We are going to start off by removing the brake caliper. The brake caliper on this particular vehicle is held in with 2 bolts. Now with the brake caliper safely suspended out of the way, we can continue on with removing the rest of the components. Next will be the brake caliper bracket. With the brake caliper removed, we can now remove the rotor. Now that we have access to the wheel hub assembly, we're going to finish with the removal procedure. To remove the center axle nut, I'm going to be using an air impact gun. What I need to stress is that under no circumstances on the reinstallation should the air impact gun be used for that center axle nut. A torque wrench should be used with the manufacturer's specified torque value. We have a few bolts that need to be removed behind the wheel hub assembly that attaches to the spindle. And lastly, we need to disconnect the ABS sensor. Now with some light force pushing against the axle, the wheel hub assembly will slide right out. The next step of the procedure is to clean around the spindle assembly where the wheel bearing had been attached to. Over the years, corrosion will start to build up, and it may be difficult to install the new wheel hub assembly. So we're going to go ahead and use a drill and with a wire brush and clean the contact surface where the wheel hub assembly is going to mate to. Now that the mating surface has been cleaned, we can continue on with the installation of the wheel hub assembly. What we want to do is pay close attention to the orientation of the ABS wiring harness and make sure that it goes back into its original locations. The reason for this is to ensure that suspension movement will not damage the wiring harness. I'm going to reinstall the 3 bolts that hold the wheel hub assembly to the spindle, and I'm going to tighten them down evenly. But these 3 bolts need to be torqued to the specification. Now that all of the components have been installed, the last step is to tighten the axle nut. I have here a specification book that tells me the torque value for that axle nut, and it is 185 foot-pounds. I'm going to set my torque wrench to that value. And I'm going to go ahead and tighten the axle nut. The last step in the procedure is to take the car for a test drive and ensure that the repair was done properly. Now that you have seen a wheel hub installation procedure, I will quickly walk you through some of the basic ABS diagnosis. There are 2 types of ABS sensors. We have the active sensor and a passive sensor. The passive sensor is the one most commonly used. However, lately, the active type is appearing more frequently in newer applications. There are 2 basic tests to determine the integrity of passive sensors: voltage and resistance. Let me walk you through the process of performing these 2 tests. So first, what we want to do is we want to set our multimeter to the resistance scale. We're going to grab our 2 leads and we're going to attach them to the actual sensor, one on each side of the pigtail. And we will take a measurement. For this particular application, it reads 1,000 ohms, which tells us that the integrity of the sensor is good. The second test you can do is with the wheel hub installed on the vehicle. What you want to do is turn the wheel at about 1 revolution per second. What you should see on the multimeter on the voltage scale should be about 50 to 900 millivolts. The testing of active sensors is a little more complicated because it requires specialized testing equipment. Unfortunately, this is beyond the scope of the video. However, we plan to address these processes in our upcoming ABS diagnosis training video. Extensive warranty analysis has shown that the leading cause of wheel hub warranty returns is due to the improper or excessive torquing of the axle nut and improper diagnosis of the ABS system. In order to reduce these returns, I would like to ask you to pay close attention to these areas of the installation process. If you do, I can assure you that you will have a successful and lasting installation of our wheel hub assembly. My name is Mike Pitton. It has been my pleasure to present this instructional video to you. Thank you for your attention.